So now that we understand what the slopes of perpendicular lines look like and what the slopes of parallel lines look like, we're going to do an example or go through the process of learning how we take one equation and find a line that is perpendicular to it or parallel to it. So the inside looks like this, and actually the steps are almost word for word exactly the same. So I'm going to go ahead and fill all the steps in so you already can kind of copy that. Well, not copy it because you don't have it, but you'll already have those steps written in. In both cases, we do have to identify what is the slope of the line they're beginning with, okay? The current line, the given line. And then what we're going to do is we're going to write a second equation, a second linear equation. If it's a perpendicular line, we're going to write that second equation with a slope that is the opposite reciprocal of the one that we find of the current one given, okay? And we're going to put that slope in for the m, and then we're going to leave the variable b, which is going to be the y-intercept. Now we're going to have to find out what the b is because we don't know what the y-intercept is, okay? And I'm going to show you how to find b. So in order to find b, once we get it into slope-intercept form, we're going to basically have the m filled in, but we're still going to have a b, a y, and an x. Well, the x and the y values can be plugged in because they're going to give us a point. They're going to tell us, write an equation of a line that is perpendicular to this line, and that line that you're trying to find passes through this particular point. That point lies on the line. So I can take those x and y values and plug them into slope form, or the points slope-intercept form, okay? And I'm going to be able to write and solve the equation for b. And once I solve the equation for b, then I have the slope and I have the y-intercept, and I just simply write it in slope-intercept form by filling in the value that I found for b, okay? So let me do this example so you can see. It says write an equation for the line that's perpendicular to this line, and the line that is perpendicular to it is going to cross through this point. Okay? So here's what I'm going to do. I can't do anything until I identify what the slope is of this line. This line is not in slope-intercept form. So if it's not in slope-intercept form, I can't just look at what's in front of the x and make the determination of what the slope is. Okay, so the first thing I'm going to have to do is I'm going to have to convert this line here into slope-intercept form so that I can worry about identifying what the slope is. And then remember, the slope is the m, the value or the number that's in front of the x. So in order to get this solved for slope-intercept form, remember slope-intercept form does y equals mx plus b. I need to get the y alone. So I'm going to add the x to both sides. And I'm going to get 5y equals, I'm going to put the x value first so it looks like slope-intercept form, x plus 10. And then I'm still not done because I have to divide away this 5 in order to be able to get the y alone. Now, on the right side, I have to divide the x by 5 and the 10 by 5. And you might be thinking, well, how do you divide x by 5? Well, remember that x really does have a coefficient in front of it. It's a 1. So really, this is like 1/5 x plus 10 divided by 5 is 2. So this equation, the starting equation, the given line, has a slope of 1/5. That's the slope of the current line. This slope is 1/5. Now the question is, if that's the slope of the line that's being given, when I write the equation of a line that's perpendicular to it, it's going to have to be the opposite reciprocal. Well, this is 1/5. So the reciprocal of 1/5 would be 5/1 or just plain old 5, right? So I'm just going to write opposite reciprocal. I'm going to write 5. But if this is a positive 1/5, then the opposite reciprocal has to be the opposite sign, which would be a negative 5. Oops. So I'm going to want to use this negative 5 in my equation of the line that I'm trying to find. So again, what I'm going to do is I'm going to use this as the slope, negative 5x plus b. Now, I got three variables there, y, x, and b. The only piece of information that I can use besides the equation itself is I can use these points right here. This is an x value and this is a y value. So that's what I'm going to plug in. For the y, I'm going to put in negative 4. And for the x, I'm going to put in 15. And then I'm going to find out what the b is, and then I'll write my final equation in slope-intercept form. So if I do the math, negative 5 times 15 is negative 75. So if I want to solve for b, I'm going to add 75, and negative 4 plus 75 is 71. So what's my equation? My equation has to include the slope, which I discovered was negative 5 because it's got to be opposite reciprocals of the other slope that's given. And then my b, or my y-intercept, is 71. So my equation, the equation of the line that is perpendicular to 5y minus x equals 10, is y equals negative 5x plus 71. That's my equation. I have negative 5 for the slope, because remember it's the opposite reciprocal of the slope given, and it's got a b value, or a y-intercept, of 71. So this is my actual answer. They just asked me to write the equation. I've just got lots of steps to get to that point. Now, when we get down here to parallel lines, everything about this is the same, with one blank, and you'll notice I left it blank. I'm going to write everything else in, then we'll come back to that blank. The process is the same. The only difference is what do I write in place of slope in that second equation? Well, we learned that if they're parallel lines have slopes that are the same. So the only difference between each of these steps is that this one says opposite reciprocal. This one is the same slope. Now the good news is they already gave it to me. The equation for the line is already in slope-intercept form. So all I have to do is look at what's in front of the x. And that's the slope of the line, and the slope of the line that's parallel to it's going to be the same. Well, it just so happens that it has a negative sign in front. Well, there's no number there. But remember that anytime you have any variable, there's always understood to be a number 1 in front of it. So this is the same thing as negative 1x. So the slope is negative 1. And that's going to be what I plug in to find the line that's parallel to this, because it's going to have the same slope, and the slope is negative 1. Now it passes through a different point, so that's the point values that I'm going to use for the x and the y. So the y is going to be 5, and the x is going to be negative 2. So the y is going to be 5, and the x is going to be negative 2, and I'm solving the equation for b. Negative 1 times 2 is positive 2 plus b. And if I subtract to get the value of b, I get that b equals 3. Now, I have the slope, and I have the y-intercept. So the equation is going to be y equals negative 1x, or I can basically turn it back just into the variable, negative x, and then the b value is 3, so it's a positive 3. So y equals negative x plus 3 is the equation of a line that's parallel to y equals negative x plus 4. It just crosses the y-axis in one different way for the point. So this one crosses at 3, this one crosses at 4. Okay? And they have to be that way in order for them to really be parallel lines. So kind of several steps involved here. You might want to study the steps really carefully. You got to remember what we're dealing with too. We're dealing with opposite reciprocals for the slopes of perpendicular lines, and we're dealing with slopes that are the same for parallel lines. And that allows us to solve the equation for b, because the b is the second part of the slope-intercept form we have to fill in. We fill in the slope and we fill in the b. So you have to find what b equals in order to finish off the rest of the equation.